Welcome to the 10th tutorial of Atmega16, and this tutorial is based on the interfacing of LM35 temperature sensor with Atmega16. The LM35 is very common temperature sensor which provides the linear proportional output to the centigrade temperature. According to this linear relation, we will get 10 millivolt change in the output voltage per degree centigrade, and we can measure minus 55 degrees centigrade to positive 150 degrees centigrade temperature. We can use 4 to 30 volts supply for LM35, and this is the typical arrangement of the circuit for LM35. We need minimum 4 volt power supply, ground, and one analog channel to measure the voltage from the sensor. So let's first connect this temperature sensor model in Proteus ISIS. For this tutorial, I will display the temperature reading on this 16x2 LCD which is connected to port C. I will connect LM35 temperature sensor to ADC0 pin. To get the temperature sensor, go to component mode and search for LM35 and select this first package of temperature sensor. Double click on it to add it into the device list. Click on OK. Now select the LM35 and place it near to the ADC channel. Pin number 1 is 5 volt, so connect 5 volt to this first pin. Pin number 3 is ground. Connect a ground to pin number 3, and pin number 2 is the output from the sensor. Connect this to one of the ADC channel. And on the sensor we have this down and up arrow to increment or decrement the temperature for simulation. Now we have to write a program to read the ADC channel 0, and we have to convert that value into temperature. So for that, first create a new project in microC compiler for AVR. First declare the pins of LCD, and don't forget to include the LCD library for this tutorial, and we also need the ADC library, so include these two libraries. In the main function, first I will initialize the LCD, then I will initialize the ADC module. Display this text on first row and first column on the LCD. Create an infinite loop with while 1. Declare an integer variable to store the ADC conversion. Read the ADC channel 0 and store the result in RES variable. Display the MSB of the result on LCD's second row and first column. And display the other 2 digits of the result on the LCD to next column locations. Compile the program and first observe the output of simulation, and on the LCD we are getting 52 but the temperature is 25, so this is not the correct value of the temperature on the display. We have to do something for this actual value. Go back to the compiler. Now here we are reading the ADC channel 0 and we are storing the result in RES variable. This is just a simple conversion of analog signal into digital. It is not the real value of the temperature. To convert this value into temperature, we have to multiply this value by the step size of the ADC, which is 4.88 millivolt if the VREF is equal to 5 volt. So just make this change and again compile the program and go back to the simulation. Run the simulation, and you will get 253 and the temperature is 25. So if I put a dot after 25, then it will be approximately equal to the 25 degrees centigrade of the temperature sensor. So for that, stop the simulation, and in the compiler now we have to display a dot here to show the proper temperature reading. Compile it and go for simulation. Run the simulation, and now we are getting 25.3 degrees centigrade. So if I increase the temperature, 26.3, 27.3, so the temperature on display is approximately equal to the temperature of the sensor. A little error is because of this floating value, because the result variable is an integer and we are multiplying that value with a float number. To turn off the LCD cursor, I put this command LCD cursor off. I add this line at the end of result. Compile the program and run the simulation. Now we get temperature 27.3 degrees centigrades. So if I go for the maximum temperature, which is 150 degrees centigrades for LM35, so we will get 150.3 degrees centigrades, and the temperature on temperature sensor is 150 degrees centigrades. So guys, this is the simplest way to use LM35 with Atmega16, and the procedure will be same for any other microcontroller. So thanks for watching, and don't forget to subscribe the channel.